In the following, I am going to show you how to do client-side code generation with Python. Before we start, note that all the files that are used in this demo can be found in the GitHub repository of this session. I use Jupyter Notebook to run the Python code, which can be installed quite easily with pip, assuming that you have Python installed on your machine. If you open the command line, you can enter the command pip install notebook to install everything that is required to run Jupyter Notebook. After the installation is finished, you can open the notebook by running the command Jupyter Notebook. If you run this command from the folder where the notebook is placed, it will directly open the right directory in the browser, where you can then select and open the notebook. As shown in this overview diagram, which was already shown in the previous session, we are now taking the XML schema files corresponding to a content model and generate Python code from that. Note, we are not generating code for Exchange at this point. This will be shown in a later session. As the content model, we use the profile situation model for accidents that was created in the session before. We will also use an example instance containing a few accidents that is valid for the created schemas to test the generated code. For code generation, we use the xsdata command line tool, which can be installed as shown here. This library generates Python classes from XML schema definition files. As a first step, we have to do a small adjustment in the configuration of xsdata. For that, we create a configuration file by running xsdata init config. Switching to the directory of the notebook, you can see a file called .xsdata.xml. If you open this file, you see that there's a field name attribute which is set to snake case. This will have to be changed to camel case because this is the naming convention of datex2. After we have saved this change, we can now return to the Jupyter Notebook and then have to run the command xsdata init config again to confirm the changes in the configuration file. Now we are ready to generate the Python code from the datex2 schema files. For that, we use the generate command with the structure style set to single package and the schema set to the D2 payload file, since this is the top-level umbrella schema for datex2, which imports all other required schemas like common, location, or situation. After we have run that, we can see in our directory that there is a Python file with the name generated, which we can now import in our Jupyter Notebook by running import generated. To test the generated code, we can fill the Python classes with an example instance that is valid for our schemas using an XML parser. We can import that as shown here. The example instance that we use in the following is placed in the folder of the notebook. Usually, datex2 is used for real-time data exchange, So the data feed would be requested via an HTTP GET request. This could be easily done here using the requests library. However, for this demonstration, we use a local file, which we load as a string. Now we can pass the example instance into the generated Python classes. For that, we define a variable data and give the instance and the top-level element of the generated classes as arguments for the pass function. The next step is to iterate through the datex2 model without having to use XML. If you have a look at the class diagram, you can see that the model entry is a situation publication. For that, we can check if there are any instances of the situation class which must contain at least one situation record. Since we use a profiled model for accidents in this notebook, we know that there can only be situation records of the type accident in this example instance. But as a first step, we can check if there are any situations in this example instance by checking the length of the array of situations. Looking at the output, we can see that there are indeed 3 situations contained in this instance which we can further analyze. As shown in the class diagram, a situation has some header information, including an information status attribute. So let's first check the value of that. Since a situation publication can have multiple instances of the situation class, we have to iterate through the list of situations, or for simplicity, take the situation at the first position in the list. And since the information status attribute is of type enum, we have to take the value of the information status. As you can see here, the information status for this accident is real. Now we can go a bit deeper into the model and check the information on the accidents. Since each situation must contain at least one situation record, we can directly access it without having to check its existence first. However, there might be multiple situation records. So as a first step, we can check how many situation records there are defined for the first situation in the situation publication. So there's only one situation record. To be complete, we can also check if the situation record is of type accident by printing the type of the situation record at position 0. Now that we have found an accident, we can extract further details on that. Let's define accident as the first situation record of the first situation in this instance. The accident type attribute is mandatory, so we can directly extract the value of that. However, there might be multiple accident types, so we have to iterate through all of them just in case there are multiple types defined. As you can see in the output, the accident is of type collision. Since there's an additional attribute collision type defined for this class, although it is optional, there might be some more information defined in there. So we check if the attribute is not none, and if yes, we print the value. And then we do the same for the last attribute of the class, which is the accident cause attribute. As you can see in the output, there is no accident cause defined, but the collision type is set to collision with animal. We can also check the time validity of the accident. As shown here, the time validity is linked to the situation record and has its own substructure, which is shown in this diagram. For this demonstration, we created a small profile of the validity model. However, an accident can only have a start time, so we check that. Finally, we can have a look at the locations of the accident that are defined in the example instance. In the profile of the location referencing model, there is only the option of defining coordinates for display and/or a point location, both being point coordinates. For simplicity, we choose one, here coordinates for display. But first, let's go through the list of situations and extract all of the locations so that we can later display all accidents that are defined in the instances of the situation class on an OpenStreetMap. For that, we iterate through the list of situations and for each of them append the longitude and latitude coordinates to a list. You can see in the output of this cell that we now have a list of coordinate tuples. In the next step, we want to show the coordinates on an interactive map. For that, I use the ipyleaflet Python library. This can be installed as shown here. From the library, we need map, marker, and marker cluster. Now, to show the locations of the accidents on a map, we have to define markers for each location. So we go through the list of locations that we have created above and create markers for each coordinate tuple. We also need a center for the visualization, which we can simply set to the first location in the list. Then we can define the map and add a marker cluster. And the last step is to add the layer to the map and show it. Now you can see that we have 3 locations corresponding to the situation instances in our situation publication, 2 of them being very close to each other. And if you zoom in, you can now see the exact locations of the accidents on the road. And that was it for my part. If you want to try it out yourself, you can visit our datex2 GitHub repository and also our YouTube channel. Thank you for watching.